Subscribe to our channel for latest video series on GATE, UGC, NET and more. Also press the bell icon so that you never miss an update on any latest video. For more information you can visit our website or call on the numbers below. So we've already looked at basic time operations that we are performing on signals. We looked at time scaling, time shifting, time reversal. Now there are several rules that we are going to use that apply to these operations, these time shifting, scaling and reversal operations when you are performing them. See, the basic rule that applies is whenever we are performing a time operation on a signal, the operation is going to apply only on time on the independent variable, only on t, not on the complete argument. That is, what I mean to say is, suppose I have got a signal like this, suppose I have got a signal ft, right. If I am performing an operation, I am performing an operation of time scaling, then this is going to become f3t, right. This is how it is happening. Now suppose initially I had a signal ft minus 3. Okay, and then I am performing the same time scaling operation, okay, similar time scaling operation. Now what is going to happen is, this is going to become f3t minus 3 and not, right, this is wrong, this is not going to become f3t minus 9. No. Why? Because this operation that I am performing is going to apply only on the independent variable t. T is the independent variable here. This operation is going to apply only on the independent variable and not on the complete argument. Similarly, if we are performing time reversal also, okay, suppose I had a signal initially, some signal like this, okay, and I performed time reversal. Time reversal means I have to replace t with minus t. The function is going to flip, the signal is going to flip around y-axis. Now what happens is, this is going to become f of minus 2t plus 5. Okay, this is going to remain plus 5 only. This is only going to be a left shift only. Why? Because all the operations that you are performing are going to apply only to the independent variable and not to the complete argument. This complete thing, this 2t plus 5 is the complete argument of the signal. So whatever operations we perform, they are going to apply only on the independent variable. This is why order of performing the operations, if you are required to perform two or both operations or all the three of operations in a single signal, order of performing the operation is going to make a difference. How it is going to make a difference? See, suppose initially we have a signal ft, okay, and we are required to perform shifting as well as scaling both in the same operation, okay. Fine. So you had a signal ft and you are required to obtain 2t plus 5. 2t plus 5, okay. So now see, there are two ways to doing this, okay. First way would be, first we perform the shifting, then we perform the scaling, and obviously the second way would be, first you perform the scaling, then you perform the shifting. So you are going to do both of them and see how the order is going to matter. So firstly I am performing scaling followed by shifting, and in the second case we are taking shifting first followed by scaling. See how it is going to change, okay. So if I perform scaling first, okay, I perform scaling first, I replace t with 2t. So the function has now become f of 2t, right. Now I have got f of 2t and I require to shift the function. Now I needed a shift of 5. So what do? I just replace t with t plus 5. Now see what happens. Only t is going to be replaced with t plus 5. Now what has the function finally become? F of 2t plus 10. But I did not need this, right? This was not required. Okay, so we needed a function of the form, a signal of the form f2t plus 5. But what did we get? We obtained a signal of the form f2t plus 10. This is why the natural order of performing operations on a signal, when you are required to scale and shift a signal, then we are going to perform shifting first and scaling second. Now see, if I had to perform, if in any case I had to perform scaling first and then shifting, what I had to do was, I should not have shifted this signal by 5 then. What did I have to do then? I should have shifted it by 5 by 2. See, then what would have happened? This would have been t plus 5 by 2, and when you just simplify it, you would have obtained 2t plus 5. So, in any case, if you have to perform scaling first and shifting next, then what you have to take precaution is that the shift that appears in the signal, you cannot give the complete shift, you have to add a correction factor, okay. You have to correct the shift and then you can perform in this sequence also. But it is advisable to perform shifting first and then scaling. Why? See, if I am performing shifting first, I replace t with t plus 5, the signal becomes ft plus 5, then I am performing scaling. So now when I perform this scaling, this is going to apply only to the independent variable t, this is not going to apply to the complete argument, okay. The complete argument is not going to be multiplied with 2, only t is going to be multiplied. So this becomes f of 2t plus 5, which was a required signal also. So whenever you can just note this. Whenever a signal of form f of at plus minus b is required, natural or correct order of operations is first shift, then scale, first shift, then scale, okay. Although you can just reverse this order also, as we have done here, see. So this was not correct, but this is the correct way. If you want to reverse the order also, then you can do it, but just take care, okay. You just have to add a correction factor, okay, add, multiply, divide, whatever. You just need to take care, take a precaution there. If you do not need to take any precaution, then you just follow this order, first shift, then scale. Okay, now this scaling I have included reversal also, because reversal is also a kind of scaling. You are multiplying, you are scaling the signal with minus 1, right. So that is what reversal is. So if operation involves shifting and reversal, then also you are just going to perform shifting first and then reversal. If a signal involves scaling and reversal, then the order does not matter, okay. You scale first or reverse first, that would not make a difference. So this is one thing that you can note. We are going to look at an example for this concept now. So we are given question. So they have given us a signal ft, which looks like this, and they are asking you to sketch f of minus 2t plus 3. So now see, the required signal, the signal that you are required to obtain involves operations on time, okay, involves time scaling, time shifting, as well as time reversal. So it involves all the operations on time that are possible. So just now we have seen that whenever we are required to perform all these operations, several operations on time, first operation that we would prioritize, first operation that we would perform is time shifting. First you are required to perform time shifting, then we would perform time scaling or reversal. So firstly we are going to perform time shifting, which means shifting this signal by 3. Now see, since this is a plus sign here, this means that I have to shift this signal to the left by 3. This is going to be time advancement, left shift. So if I just sketch ft plus 3, okay. So previously this signal was lying between minus 2 and 2, and now if I just subtract 3 from all these instances, it is going to lie between minus 5 and minus 1, okay, minus 5 and minus 1. if I just sketch it. Okay, so this is how the signal is going to look like, right? So this is how ft plus 3 is going to look. So now we have already time shifted the signal. Then the next operation that we are going to perform is time scaling. See, you could take reversal first or scaling first. I am just taking scaling first. So the signal is going to become f2t plus 3. Now when I am going to scale this signal with 2, what happens is all these instances, all these time points, time instances are going to be divided by 2. This is going to be time compression of the signal. So this point is going to be minus 5 by 2, this point is going to become minus 1 by 2. So this is what the signal is going to look like. Fine, so this is now okay. So this is how this time compressed signal is going to look. Now the last operation that I am performing is time reversal. When I perform time reversal, signal is just going to flip, okay. This is going to make a mirror image about the y axis, which is why the signal is going to now lie between 1 by 2 and 5 by 2. Fine, so this is how our required signal is going to look like. Okay, this is 0.1, right. So this is how the final signal you are going to obtain. Now see, there were several ways to obtain this signal from this one. Okay, we chose the sequence of shifting first, then scaling, then reversal. If you all want to choose some other sequence of operations, suppose you want to perform shifting scaling first, you can do that also. Just perform scaling first, that is, first you are going to scale this t by 2t. The signal you are going to obtain is f of 2t. Next you want to perform scaling, then what you have to do is you just have to take the precaution that the shift that you are providing should not be 3, it should be 3 by 2. Okay, so with just a slight precaution you can just change the order of the operations also. If you want to follow the same order, then also it is not a problem, okay. Natural order would be shifting first, then scaling or reversal. So this is going to be the final signal that you are going to obtain.